Hi, I'm Jason Lillywhite with Lillywhite Water Solutions. Over my career as a water resources engineer, I've run into similar complex challenges when it comes to agricultural water delivery and when that's in combination with hydraulic routing. So the existing tools, mainly being something related to EPA Net or one of its wrappers, was useful for certain things, but when it came to an integrated systems approach, just kind of fell short. So I'd like to introduce to you HydroSystem. This is a specialized modeling platform I've developed, and it's specifically developed to handle dynamic irrigation scheduling and network hydraulics combined. So today I'm going to give you a quick demonstration of how it works and the kind of problems it can solve. So right now we're looking at a little system that I built, but what we have here is in this magenta, the magenta lines are the pipes and the blue are the hydraulic delivery nodes for each of these fields that are outlined in green. I have another area over here on the right that represents an industrial zone. So let's first talk about the hydraulics. So I've got a water source over here on the left, and then this link to the first node is a pump. So if you look at the properties dialog, you can see here that we can change it from a 3-point curve to a single point curve. Pretty basic stuff here, essentially allowing you to quickly simulate basic pumping dynamics. And then the water flows into a main pipe here and then goes into the distribution system. As you can see, the pipes here have a length. This is auto-calculated based on GIS. If we click on a node here, you can see it says a junction. And then it also has the elevation calculated from GIS. If you click on a node that's inside of an area, then you can see it's attached to this land. It says Area 3. So we click on this area. This is Area 3. And you can see here that it has a computed area also based on GIS. And then we can select a crop type, and this comes from regional crops for the area obtained from USDA. And so I can change this. Right now I'm setting it to alfalfa. The next input down, well, I don't need to spend too much time. You can go to my website and check all of this out. But the next one I want to show you is the irrigation method. And this also is a list that's generated by downloading information from USDA. And depending on which option you pick here, it has certain requirements, such as minimum pressure. So if the delivery node does not provide that pressure, then we will not be able to deliver water to that field. I'm going to change this from center pivot down to wheel line. It also includes an efficiency, which has an impact on the water demand. Below that is the soil composition. This is also obtained from GIS information. So it lists all of the different types of soils there, and that drives also the demand for water. And so, by the way, let's talk a little bit about how we calculate these demands. We are using a reference ET from FAO-56 manual. If we go to this menu bar up here at the top, and we go to library, you can see we can look at all of the crops in this area. And within each of these, you can click on a plot to show the localized KC values over the irrigation period. And this uses a dynamic growth tracking using growing degree days. And this is a better approach than just forcing these values to be static over a calendar period. So it's based on temperatures. So it's a much more dynamic approach. If you go to a different crop, you'll see that the timing is different. So those are the crops that we can choose from. You can also go to the list of our irrigation methods here. In here you can set the required pressure and the unit demand per acre. Also, importantly, is delivery schedules. This is always something that's a little bit tricky. So we can set up delivery schedules So we can call this schedule 1, and we can say we want this to be a 72-hour duration. We could change this to we could put this on a 14-day interval, create a new one, a new schedule, a separate one, and also put it on a 72-hour duration. Oh yeah, and then we can change the interval also to 14-day intervals, and then we can just move these sliders back and forth to essentially lock in the schedule for these different rotations. And then what we can do is we can assign a pipe. So let's say on this lateral going to these fields, we want to apply that rotation schedule. So you can go to this pipe and you can say, okay, I want this to have this delivery schedule. Now this is a little more complicated in this model because we have 2 pipes coming over to this area. So we would have to set both of these to that schedule. But for now, I'm just going to leave these schedules off, and I'll leave discussing schedules for a different video. Okay, so all of these pipes can send water at any time. We're not closing them down. We're just letting the model calculate the flows. So let's go ahead and run the model. So what's happening here is on my server, EPA-NAT is running, producing results, and sending the results back to this browser. Okay, so all of the nodes are blue, and you can go to my settings, or go to the settings here and look at the visual, go to the visual settings, and you can see what the colors mean for nodes. So in the case of nodes, blue means we have greater than 50 psi. So that means we've got plenty of pressure throughout all of this. If we click on one of these areas, then you can see how the water is being delivered. We can double click on this chart and get a better view. And also in this chart, it's showing the wilting point and the field capacity and how our soil water matches up to that. So what it does is the water will be delivered based on trying to provide an adequate amount of soil water at the times that work for it. So you can see it turned off when, let me expand this again, the water deliveries were increasing the soil water. There was a little bit of rain that occurred right here that made this come up a little higher, but then as it's dropping down, then it turns back on again. And essentially what will happen is it will turn on if it ever starts to approach the wilting point, but it will also look at the pressure at the delivery in the hydraulic system. And so it's kind of a smart way to figure out what the deliveries can be to each of the fields. But now I realize that a lot of irrigation districts use rotation schedules, and that's why that has been implemented. But again, I'll talk about using the scheduling in another video. But in this model, what I want to do is I want to show how we can look at a scenario where we've got some sort of new demand being applied to the system and see how that impacts everything. So in this case, we're going to create a new industrial zone. So this is a different type of area. If you look at these other areas, when you click on them, up here at the top it says agricultural. But on any of these areas, you can change that to a municipal type. And in this case, I've got a new land use category. I've called it data center. But you can choose from a whole bunch of different ones that are actually defined in our library up here. So go to, in this case, industrial land use. And you can see I've added this new data center, and I've given it a total constant demand. You can apply patterns. So in our library, we have patterns here, but we can talk about that later. Right now, it's just a constant demand of 1,000 GPM. So a pretty significant flow rate relative to the rest of this system. So now what I want to do is I want to create a new scenario. So I come up here to the scenario drop list and select this new data center. And then you come over here and you see that in the properties of this industrial area that we now have 500 as our demand for this for this area. So I've overridden the base default demand, and I just called it 500. But if we then switch back to our baseline scenario, now you can see that it's 0. Okay, so let's go ahead and run both of these scenarios. I'll just start over and run the first one again. Okay, I'll switch this back over to our new scenario and run that one. Okay, so now what we can do is switch between these, and you see that the colors are changing of our system. And when we go to the new scenario, you can see we've got some red, and this indicates a low pressure. You can see that there are times when our pressure has dropped significantly, and luckily we have a pipe network. We can deliver water over to this other node over here that has just barely enough pressure to get water over to this field. But we are seeing that our pressures are getting lower. So this new demand over here definitely had an impact. We can see other impacts as well if we go up here to the results and go to cumulative summary. And in here we can see in the top left, we can look at cost of pumping. So under our baseline scenario, our cost of pumping was just under $30,000 for that time period. And then with the new data center installed into the system, we have increased our pumping cost to $50,000. You can also see that the total water delivery has increased by that new industrial demand over there. There are some other results that you can look at, such as time series results here, and some other global things. We can look at, for example, all of the junctions in our system. This is similar to what you might see in EPA net. We can look at all of our pipes and what junctions they're connected to, and so forth. So in general, what this model does is it provides you with an integrated approach to modeling your agricultural system in a unified way. Now, we could have multiple networks in here. We don't have to have just one pipe network. We could add other networks in here by creating a totally new separate water source over here, and then go ahead and just start building our network of pipes linking these nodes to various other fields, and then just start creating our fields and so forth. So that's essentially a brief overview. I'll plan to create some more videos to show more details about specifics of this model. I hope you find this interesting. Please come check out my website if you want to check this model out. You can play with it yourself. It's at lillywhitewater.com. And also, if you're interested in me helping you build a model for your specific application, please come check out my website, and we can talk.